Okay, so this video is going to be regarding sample distributions. I have here an example problem that I found in an assignment of mine, and I'm going to be solving it and explaining how to actually get the answer. Now, before we start, it's important that you are familiar with a few things, namely normal distributions. What do I mean by this? Well, you need to be familiar with z-scores and the standard normal probability table. You need to be able to find a standard value and find it on the actual table to get an associated proportion. So basically, you need to know how to use and to solve some basic normal distribution questions. So I'm going to be assuming that you are familiar with it from this point on. Let's get started. Daily water intake, including water used in drinks such as coffee, tea, and juice for Canadian adults, follows a normal distribution with mean 1.71 liters and a standard deviation of 0.28 liters. First off, can you calculate the probability that the mean daily water intake for a random sample of 2 Canadian adults is less than 1.5 liters? If you can, enter the probability in the answer box. If you can't, type the word no. So what this first part is asking you is it even possible to calculate a proportion, because notice here the sample size is only 2 people. It's very small. So using such a small sample, is it even possible to find the distribution? Well, it is, because if you notice, the population they mention is normally distributed. And there is a rule, or sort of an observation, that whenever the population of something is normally distributed, the sample is always going to be normally distributed as well. So that means we can answer this question even if the random sample, is only two people. It's very small. We can still answer it because it's still normally distributed. So as you can see, the answer is right here. I will show you now how to get that answer. The first step here, the first immediate goal, is going to be to standardize this one value right here. What we're trying to find is the probability that a random sample of 2 people is going to be less than 1.5 liters. So we need to standardize 1.5 liters first off. But there's an issue, because the normal method of standardizing a value is using the following formula. You take whatever value you're trying to standardize, you subtract it by the mean. So this mean is usually it's of the population. So the mean of a population is usually denoted as mu. That's how this Greek symbol is pronounced. It's mu. It stands for the population's mean. So population's mean. So you take the value you're trying to standardize, you subtract it by mu, and you divide it by the standard deviation of your sample. So the standard deviation of your sample, it's not going to be the standard deviation of your population. So this is where another problem occurs, because we do have noticed the information we're given initially is that it's a normal distribution, and we're given the mean of the population, and we're given the mean of we're given the standard deviation of the population as well. But we need the sample standard deviation. Well, we have to use yet another formula to determine the standard deviation of the sample. This formula uses the standard deviation of the population, and it is as follows. You're going to take the standard deviation of the population, which is going to be denoted as sigma. So sigma is another Greek symbol. It stands for the population's, sorry, it's a bit messy. That's the population's standard deviation, or so. Very messy. So it's going to be the standard deviation of the population divided by the square root of your sample size, which is going to be n. N stands for the sample size. So the standard deviation of our population up here, as you can see, is 0.28 liters. So it's going to be 0.28 divided by the square root of our sample size. And if we look at the problem down here, it says can you calculate the probability that the mean daily water intake for a random sample of 2 Canadian adults is less than something? So our sample is going to be 2. And what we're calculating right now, just to remind you, is the sample standard deviation. Now, if you were to actually calculate this out, you would get a value somewhere around 0.197989 or so. That's enough decimals to get a reasonably accurate answer. So this value right here is going to be our standard deviation of the sample. So this is going to be the sample standard deviation. Standard deviation. Just let me take the time to write that out. So that's sample's standard deviation. That's what we can use in this formula right over here. So now we have all the information we need to actually answer this question. So the first step is to standardize 1.5 liters. So let me change color to that. How about red? So 1.5, because that's the value we're trying to standardize. That's what x would represent here. Subtract mu. Mu, as you can see, is the population's mean. So subtract, we're given it as 1.71 liters. So 1.71 divided by S. S is going to be the sample standard deviation, which we just found down here is 0.197989 or so. And this calculation here will give you a standardized value of this that we can actually use on a standard normal distribution to find the proportion that's associated with it. So if you were to do this on your calculator of some sort, you would get a value roughly around -1.06. Now, since I'm going to assume you are familiar with a normal distribution, if you were to, this is a value that you would find on it. So if, let's say, for example, this is a standard normal distribution, the mean would be 0, and then you would have some things over here that would represent your standard deviations away from the mean. What we found here would somewhere it would lie around this location right here. Let me just change color to really show that. It's going to be roughly around here. And whenever you're dealing with normal distributions and you find standard values to look at them or place onto them, and you want to use a standard normal probability table, remember the table I mentioned before, you should be familiar with using that. Whenever you put this value into it, you're going to get an associated probability or proportion that's going to be towards the left side. So if I were to take this value and put it into the table and check out what kind of value it spits out, I'll get a value that's going to be basically everything that fills up the left side of what I just got right here on the actual normal distribution. And this proportion, because that's what it's shooting out, this proportion is equal to saying that's the probability. Now, what does that mean? Well, since a table only shoots out things towards the left side, what you're essentially getting is a probability that whenever you take a sample of 2, a random sample of 2, there's a whatever probability it shot out chance of getting something that's less than it. Because notice, it's always something towards the left side, or less than it. So if you were to put this value on the table, it turns out you will get a value of roughly 0.1446. And as you can see, this is our answer. So this is the probability that you will, out of a random sample of 2 Canadian adults, you will get something that's less than 1.5 liters. So as I said, it's quite important that you know about normal distributions. It is highly important in order to actually answer anything about about sample distributions. You need to know a decent amount about normal distributions and how to answer those kinds of questions before you move on to sample distributions. So I hope this helped, and hopefully I didn't confuse it too much. If you have any questions, please ask them in the comments section below. I will do my best to answer them in a hastened manner, so it'd be very quick. And have a nice day.